Alright, welcome. In this video, I'm going to be working an old linear algebra unit 1 test. This is the test I gave when we were all remote, and so I've posted this as a practice test for linear algebra now. And so, we've got this situation where we've got V and W are vectors that are given, point P is given, N and Q we can figure out using the points and the vectors, and then A and B are some matrices over here. And so it's just going to start asking us some questions. I'm going to try to get through all of these. I'm recording this before school, though, so I might have to not do one of them that's, definitely not going to appear on this year's test. That distance from a point to a line, I'm not going to ask you that on the midterm, so that's red, and I might use that eventually, but I'm looking to start with black. All right, so find theta, the measure of angle in PQ. Okay, so it's just going to be the measure of the angle between vector V and vector W. So I'm going to go over here and I'm going to say, all right, V dotted with W, the cosine property, is equal to length of V, length of W, cosine of the angle in between them. Okay. And so we can compute the dot product. It's going to be negative 12 minus 16. Should probably keep track of this. Negative 12 minus 16 plus 7 equals length of V. 9 and 16 is 25, plus 1 is 26. Length of W is going to be 16, and 16 is 32. 32 and 49 is going to be 81. So I take the square root of 81 and I get 9. And then we have a cosine theta. This is the type of thing that's going to require a calculator, and but maybe I'll start solving at theta first before I pull out the calculator. It's going to be, I'm going to combine these. Negative 28 plus 7 is negative 21 divided by 9 square roots of 26. Okay. Meaning that theta, if I solved for it, I would need to use inverse cosine, and in there I would put negative 21 over 9 root 26. Okay, and I'm going to just say that this is the type of thing you could type into a calculator in degree mode and round to the nearest degree, and that would be fine, right? It's going to come back obtuse because we're taking arc cosine of a negative number. Okay, so that's interesting. Figure not drawn to scale, right? Okay, number 2, we're going to find V crossed with W, and then I think that's going to help us find the equation for the plane that contains N and P and Q. All right, so, but we'll start with number 2. V crossed with W, okay, so we write in I, J, K. V is 3, 4, negative 1. Okay, see that? And W is negative 4, negative 4, negative 7. All right, so it's going to be I times negative 28 minus 4 is negative 32. Minus J times negative 21, okay, yeah, plus, or minus negative 4. Negative 21 minus negative 4 is negative 25. Plus K times negative 12 minus negative 16 is going to be positive 4. Okay. Right, we've got V crossed with W, and then we're going to use that probably to find, an equation for the plane that contains N and P and Q. Okay, so I'm going to say all we need is a point and a normal vector. We just computed a normal vector because V crossed with W is going to give me this vector out towards you from P, or really from anywhere. Right? It's P is not the origin, but it's still a vector that's going to sit orthogonal to the plane. And with the point P, which is 1, 1, 1 up there in this normal vector, negative 32, 25, and 4. Then I'm going to write my equation for my plane. It's going to be negative 32 times x minus the x coordinate of the point I know is on the plane, plus 25 times y minus the y coordinate of the point I know is on the plane, plus 4 times z minus the z coordinate of the point I know is on the plane. That's going to all add up to 0. Okay. And number 4, then we're going to write an equation for line L, which passes through the other 2 points, N and Q. All right, so the vector, let's see, I remember that this one's a little tricky getting vector NQ right. So V goes up this way, W goes back that way. So I think it's going to be, I feel like it's going to be V minus W. That doesn't look quite right. No, V minus W is going to put me over there, and that's, okay, so maybe W, that's just going to keep putting me over here. But if I do V plus W, I'll end up over there, and that's not it. I'm going to think about this while it's paused for just a second. All right, so I've decided I'm going to use V minus W. Okay, so I've got V and W here. Here's my little diagram, V and W. Negative W is going to go back this way, right, from the end of V. And so if I do V minus W, that's going to give me this vector here, which is equivalent to that vector up there, which is Q to N. Okay, I guess I could make it the negative. So evidently W minus V is going to end up being the same as, I don't know. Whatever. I'm not going to think about this too hard. But I know that V minus W is getting a vector that goes from Q to N. Okay? So I'm going to say that this is V minus W. And that's going to be my trajectory vector. And hold on a second. And so I've got V minus W there. And then I'm going to need points N and Q. N I'm going to get by taking point P and adding the coordinates of vector V. So N is going to be P basically plus V, right? So 4, 5, 0. And Q is going to be, I'm going to take P and I'm going to add W to it. So I'll have negative 3, negative 3, negative 6. And I'm forgetting, I don't even need Q, right? I just need 1 point in the trajectory, and I'm gonna go with N. You could go with Q if you liked, if you happen to compute that first. But we know that to write the equation for line L, we're gonna just start with a point, 4, 5, 0, and add any multiple of the trajectory vector. So 7, 8, 6, multiplied by T. Right, because it's any possible scaled up or scaled down version of this plus that point that's going to give us access to all of those points. All right, so we're going to say that this is L of T is going to be 4 plus 7T, 5 plus 8T, and 0 plus 6T. And there we've written ourselves an equation for line L. Okay. Yeah, I think I'm going to decline to do the distance from point P to L. Maybe I'll just give you a quick sketch of how you would do that. Is you would find, let's see, yeah, you would get a vector from P to a point on L. But we already have a couple of points on L that we've just written down the name of. So maybe you would, find the vector from P to Q, which I think is W. And then sketch that one in red. Okay, you would find the projection of P onto Q, right? So that's going to be that. And then you would subtract that projection from P to just get this orthogonal part, and then you would compute the length of that vector. Okay, that's the plan. Is that you compute projection of this onto this vector, and then you subtract that projection to get the rest of this, and then you take the length of this. Okay. But that's going to be all. That's all I'm going to say about that, because I'm not going to ask you to do that on a test. All right, now we're just going to do a little bit of matrix multiplication or explanation of why the product is undefined. Oh, yes, I liked these because they couldn't just jam it through a calculator, right? Because that K and H. That was clever of me. All right, so AB is going to be defined because I've got 3 here and 3 there to multiply by. So I'm going to do that. And BA is going to be undefined because of the dimension mismatch. Okay, so that what number is the 6? Okay, BA is going to be, I'm going to copy it, 210, 0, negative 1, 1, 1, 0, 1, multiplied by K10 and HO3. All right, so this product, I'm going to start in the top left. It's going to be 3 by 3 multiplied by a 2 by 3. We're going to end up with a 3 by 3 after. So it's going to be, right? 3 by 3 by 3 by 2 is going to give me a 3 by 2 at the end. I was like, yeah, that's just, I don't see where I'm going to get that third column. But 2K plus 0 plus 0. Okay, that's 2K. Move over to the right. 2H plus 0 plus 3. So that's going to be 2H plus 3. Okay, moving down 1. 1K minus 1 plus 0. So that would be K minus 1. And moving to the right. 1H plus 0 plus 0. And then over here in the bottom left, okay, bottom left, I'll have 0K plus 1 plus 0, 0H plus 0 plus 3. And then that's BA. Number 7, AB, well, wait, goodness, I just did AB. 6 was asking for AB, I just wrote it down wrong. And then this is going to be BA. Hey, are you outside? Yeah, I'll be there in a second. All right, I'll do that in a minute. Thank you. And so B is a 3 by 2 times A, which is a 3 by 3. These are not the same, so I'm going to say that this is undefined. And that's all for this practice test. I hope this helped. Thanks for watching.